Hello everyone, welcome back to the channel. In today's lecture, we are going to explore a very important concept in microcontroller programming. Lecture 5, Addressing Modes in the 8051 microcontroller. Before we begin, let's understand the simple idea. Whenever a microcontroller executes an instruction, it needs to know where the data is located. The method used to specify the location of data is called an addressing mode. In this lecture, we will study this concept in detail. First, we will learn about the different types of addressing modes, such as immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, index addressing mode. Each of these modes provides a different way to access data efficiently. Next, we will understand the working of addressing modes, where we will see how instructions like move A, has 25H or move A, are not actually fetch data from memory or registers, right? We will also analyze how the microcontroller internally processes these instructions using registers, memory locations, and data paths. Finally, we will discuss the application of addressing modes, when to use each type in real programming scenarios such as fast data access using registers, accessing memory location directly, working with arrays and lookup tables using index addressing. Understanding addressing modes is very important because it helps you write efficient, optimized, and faster programs in embedded systems. So, by the end of this lecture, you will not only understand the theory but also how to apply it in real coding situations. Let's begin. Now, in this lecture, we will cover just a thing. Just wait, we can take a pen, right? First of all, types of addressing modes, right? We will see in the detail. Second thing, working of addressing modes. Also, we will see of this. Applications of addressing modes, right? We will see in the detail, right? One by one. First of all, recap on the memory organizations of 8051 microcontroller. We have already studied in the previous lecture. First of all, we covered these things. Internal memory of 8051 microcontroller, right? Second, we also covered this thing, special function registers. The short form generally we use here, SFRS, right? In the next thing, we also covered this external program memory, right? In terms of RAM or in terms of ROM. Both memories we have already discussed in the previous lecture. Last one, The already we have discussed regarding the external data memory, right? We have covered these topics in previous lecture. Noted? Okay. Now we will see here after the lecture of this we learned about these things. First of all, identify and differentiate between the various addressing modes of 8051 microcontroller. Right? Second thing, we also learn about this, analyze how addressing modes access operands, right? Data elements. We will see one by one here. Choose appropriate addressing mode. This is the third point. Choose appropriate addressing modes for given programming scenarios. Okay. So now we can start today's lecture. Now addressing modes of 8051 microcontroller. Right. First of all, we will see the what is the instruction, right? Instruction basically in this way you can see, suppose move a comma has 25h. This is called the instruction. What is the instruction? Instruction is a command to the microprocessor or microcontroller. Now we will see here this one, microcontroller, to perform a given task on a specified data. Okay. Now we come on the each instructions has two parts. Okay. Suppose this instruction has two parts. First part, that is the op code, that is the operation code. This thing is called the operation code. We can say op code, right? That means task to be performed. Next thing, operand. Okay, operand is nothing but this operand, this one and this one. Okay, this operand is called the destination operand. This operand is a source operand. Okay, so basically this data copied from here and paste in this register. Okay, this is the thing. Now we come on the operation operand or data, right, can be specified in various way. It may be included first 8-bit data or 16-bit data and internal registers and memory locations. Okay, these things can be done in this case. Okay, now in some instructions the operand is implicit in instruction, right? The way of specifying an operand in an instruction is called addressing mode. Okay, now we come on next slide. Addressing modes of 8051. This is the basic structure of the addressing mode. You can see here in the middle, this is the addressing mode, right? Number of addressing mode is available, right? So first we consider this is the immediate addressing mode, right? Second thing, register addressing mode. Third thing, register indirect addressing mode. Fourth thing, direct addressing mode. And last, indexed addressing mode. Okay, these are the complete structure of the addressing mode, right? Now we can start the summary of this structure, right? Now let's understand the different types of addressing modes in the 8051 microcontroller. As you can see in this diagram, addressing modes define how the microcontroller accesses data for any instruction. Let's go through each type one by one. First, immediate addressing mode. In this mode, the data is directly provided inside the instruction itself, right? So the microcontroller does not need to access memory separately, right? This makes it very fast because the data is already available, right? For example, move A, has 25H. Here 25H is the immediate data. Also we will see in the detail in next slide, right? Next, register addressing mode. In this case, the data is stored inside registers like R0, R1, etc. Since registers are inside the CPU, access is very fast and efficient. For example, move A, R1, right? Now, direct addressing mode. Here the memory address is directly specified in the instruction. The microcontroller accesses that exact memory location. This method is simple and easy to implement. For example, move A, 30H. Here 30H is the location of the RAM. Understood, right? Next thing, register indirect addressing mode. In this mode, a register acts as a pointer to a memory location. Instead of giving the address directly, we use a register like R0 or R1. Remember, this allows dynamic memory access, right? Which is useful in loops. For example, move A, @R0. Remember, right? Finally, index addressing mode. This mode is mainly used for array and table access. Here, an index register like DPTR or PC is used along with an offset to calculate the address, right? It is very useful in lookup tables and data processing. So, to summarize of this thing, immediate, that is the fastest, data inside instruction, right? Register, fast access using CPU registers. Direct addressing mode, simple memory access. Indirect, flexible and dynamic access. Index addressing mode, best for arrays and tables. Understanding these addressing modes is very important because they help you write efficient and optimize programs in embedded systems. Right? Now we can move for the functioning of this. You can see here, right? In the immediate addressing mode you see, right? We can take a small example here. You see, we can take an example. Suppose we can take here the move instruction, right? Move A comma has 25H. Okay. So remember this value is the constant. Remember the signal sign should be this form, H sign. H sign is given, that means this function, this value is the constant value, right? This constant value is called the immediate addressing mode, right? Data in instruction, fast access, right? In this case. In the register addressing mode, this is the thing, just a move A comma R naught. So we can represent this instruction, the content of the register R naught. Remember the thing of this instruction. The content of register R naught is copied and transferred in the accumulator. Is nothing but accumulator register, right? This is basically the register storage efficient operations. Okay. Now we come on the next, register addressing mode. Register indirect addressing mode. So we can take an example, move, that is the opcode, operational code, that A, that is the thing, right? A accumulator register, and indirect addressing mode. So we can represent this at the rate. Okay, and R naught. We can use here R naught or R1, right? Any two registers we can use here. That is the thing of the indirect addressing mode, right? In this case, the register as a pointer, this register just like use as a pointer, right? So we can take a content, or we can take find a value from this location and copy it and transfer here. Dynamic memory access, this one. Next thing, we come here, direct addressing mode. So we can take an example here, move A comma 30H. Suppose some value given in this address, right? The value copied from this location and transfer here, right? This is basically the source operand. This is the destination operand. Okay, transfer from here to here. Okay, this is basically direct memory access and simple implementation. Last one, the indexed addressing mode. Okay, this is basically the index calculation and array accesses. We can take an example, move C, you represent this thing. C, that is the code, move code, right? And A that is the register, and we can use here the memory at the rate A plus DPTR. Okay, this is the 16-bit register we have already seen in the previous lectures regarding this, right? This one. This is the 8-bit register. Okay, so we can change. This is the fix. Basically, we can define some memory location. We can add the things by using this A. We can find the data. We can use as a lookup table, right? Array access purpose. We can use this index addressing mode. Remember, these are the instruction we have already seen now. Now we come on the next slide, right? Addressing modes of 8051. Basically, we have seen in the previous slide. Immediate addressing mode, this is just like a summarized thing, right? The source, just a thing you see, source operand is a constant, right? We have seen in the previous, right? You see, the immediate data must be preceded by the pound sign, right? This is the sign is called the pound sign, or we can say the hash sign, right? The example of this, move P1. What is the P1? P1, that is the port of the microcontroller, right? 5 this is the value is called the constant value, right? This value is copied and transfer in P1, the explanation already given here. After writing the instruction of this, if we want to include the comment of this, so we can use this sign, okay? This sign, semicolon, and we can write anything, right? That means our programmer not included this comment. This is for our understanding only. Remember, right? One more important thing, we can take something here, just noted. Suppose the value here in this way, we can represent pound sign and F2H. Okay. So this is the basically wrong thing we can represent here. Remember, because our assembler read out this is just like a variable thing. Okay. So suppose we want to use here the any variable type, so we can put here the zero values, right? So now we can use this zero value, 0 F2H. That means this consider that is the hexadecimal value. Remember, right? Next thing, register addressing mode. Okay. So in the register addressing mode, you see here, the use registers to hold the data to manipulate it. Okay, you see here, we can take example. We have seen in the short in previous slide, but now we will see here in the detail. You see, move A, that is the register, and R0. The copy contents of R0 into A. That means the copy of the content of R0 register and transfer in the accumulator. Okay. In the same thing, we can take another example here. Move R2 comma A, right? the content of A is copied and transferred into the R2 register. Understood? Okay. Now the source and destination registers must match in size. Remember, right? Source and destination registers. So this is the destination register, this is the source register. Note it. They should be the match in the size. Okay, the same size of the register should be used in the source and destination, right? Now we can take here the movement of data, right? Movement of data between Rn. Rn is nothing but R0 to R7, right? 8 registers basically, right? Is not allowed. Okay, understood? R0 to R7 register is not allowed if we want to transfer data. You see here, right? A, that is the accumulator register, R0 is the simple register, right? Why? Why? Because our RAM of 8051 microcontroller has the number of register bank 0, 1, 2, 3, right? So these registers are given, R0 to R7 registers are given in the same banks. That's why this is very difficult to just locate the values from here to here, right? This is the thing. Now we can take a next thing, direct addressing mode, right? So it is most often used to direct addressing modes to access RAM, okay, location 3027FH, right? These are the locations of the RAM. We have already studied the all locations, how many locations are given in the RAM, right? So you can see in the previous lecture regarding this. Contrast this with immediate addressing mode. There is no pound sign, remember, in the operand. Okay, this is the only difference between the immediate addressing mode or direct addressing mode. Okay, we can take an example here. Suppose we can take here move a comma pound sign and 25h. Okay, so we can take here in this way move a comma 25h. Only difference is this sign difference. Okay, this is the immediate addition, means this constant value as it is value copied and transfer here. But in this case, not as it is value you can copy it. You can copied value at this location, right? This location and transfer here. Understood? This is the difference between the indirect addressing mode or immediate addressing mode or direct addressing mode. Noted. Okay. Next thing, the example already given here, you see move R0 comma 40h, right? The copy content of 40 location in R0, right? And the content of the A is copied and transfer it this location, right? Okay. Now we can take another thing, register address indirect addressing mode, right? You see here only register R0 and R1 are used for this purpose. Remember, only two registers we are using here for indirect addressing mode. Remember, when R0 and R1 holds the address of RAM location, they must be preceded by the sign at the rate. Remember, right? We can take example here. Move A at the rate R0. This is the symbol, right? This symbol represent the just a point out the thing or location, right? Copy contents of memory location pointed by R0, okay, into A. Remember? Okay. Now we come on the last addressing mode, that is the index addressing mode, right? See here, index addressing mode is widely used in accessing data elements of lookup table, right? Entries located in the program ROM. ठीक है, ROM. The instruction used for this purpose, move C A comma at the rate A plus dptr. We can see here move C A comma at the rate A plus PC, right? We can use dptr or we can also use PC, right? Any one we can use for this purpose. Use instruction move C. C, that means code. Okay. We have already seen the previous slides. The content of A, right? Content of A are added to the 16-bit register. This one, है ना? To form the 16-bit address of the needed data. Right? Basically, we can represent in this way. Suppose we can take just a location. We can location here, this one, 4000, right? This is 4000 location, memory location, है ना? This is the memory. First location is this, right? So this is the initial address of this location, right? What we want to take a value from this location, right? This one, this is the second or third location, we can say, right? So the address location of this 4003 here. So this three value we can add through this accumulator, right? Or this accumulator, right? This dptr represent the initial address, or this thing we can add or we can find the appropriate value, right? Now, summary of this presentation, we explored the addressing modes of the 8051 microcontroller. In this, the covered key components are immediate, register, direct, indirect, and index addressing modes, operand access techniques using internal RAM, registers, external data. Okay. Importance of selecting efficient addressing modes for better program performance. Okay. In the next class, we will dive into the instruction set of the 8051 and explore basic assembly language programming. Right? Summary of this unit 1. right? You see here the basics of microcontrollers, architecture of 8-bit microcontroller, pin diagram, memory organization, addressing modes, right? We have completed this part now, right? So we will dive into the instruction set of the 8051 and following key topics, right? This is the basically brief overview on the unit 2, right? This one. Data transfer, arithmetic, logical, conditional control transfer instruction, unconditional control transfer instruction, right? Basic assembly programming, software delay generation, right? Noted? Okay. So sample questions already given here you see, right? And solve this question and provide this answer in the comment box of this lecture, right? Thank you very much for listening me.